Hey, hi folks. In this particular video, what we'll be going to do, what I strategize my plan is basically to prepare ourselves, okay, for in this particular strategic time, we have to prepare ourselves for the data science interviews. Okay, so what I'm gonna do is for the 30 days, regularly I will be going to putting the content on the data science basically. So which are the particular interview questions? Okay, so freely resources available in over the internet. So what I will be doing is I will be picking any of the random, not specifically towards one company or anything. I will be taking generalize the several interview questions. Okay, so we'll make it understand the question and make it very strategic way and understand what this particular material is about to say and try to learn it and putting into the one particular obsidian, and I will be going to share into the Google Drive. If you wanted like particular that canvas, you can. I will be sharing that as well. Okay, so you can just have a grasp on it and understand the what's that specific is talking all about. Okay, to my channel, folks. My name is Aakash, and in this particular video, we'll be going to explore the interview question day one. All right. So that's it about this video. We'll be going to discuss about it. Into the details, we'll be going to talk about it. Okay. All right. So jump to the straightforward to understand this particular video. So what is they are talking about is what is the difference between AI, data science, machine learning, and deep learning. All right. So DL is nothing but deep learning. ML is nothing but machine learning. So if you don't know about specifics about what's machine learning, deep learning, don't worry about it. We'll be going to this 30 days, we'll be strategically planning for only for the data science interviews, machine learning or data science interviews kind of a thing we'll be going to talk about. Okay, so this is the diagram which they have talked about. Okay, so we'll just copy this and we'll just straightforwardly understand. Okay, so what I do is here I will create uh, another here by one folder called as data science interviews. Okay, so I'll just rename this data science interviews. You can do that as well, folks. Like, don't depend on this myself itself. I will be going to create like that. Okay, I will be just creating here and creating a note of it. Okay, if you want, I can create a canvas. All right. So what we do is we'll just paste it here. No, here it will not can't create. Okay. Okay. So what I do is this image is okay. Pasted this image. Okay, that will be not visible to you folks. Why? Because it is exporting here. Okay. So now uh, question number one. Okay, data science interviews. Okay, so I will just write it as data science interview questions. Okay, so parallelly I'm just writing this. Okay, questions for day one. Okay, I'll just write it like this, day one. So if you want, you can change the name as okay. Okay, so instead of that, we'll just rename it as uh, day one, right? Day one. That will be fine actually. Day one. All right. So the question what they are able to see. The question number one. Okay. What's the question is about? What is the difference between AI, data science, machine learning, and deep learning? Okay. Don't ask me this question will gonna ask in the interviews or not. Just try to understand. You will get a broader perspective, folks. Okay. Okay. So in this particular material they are talking about artificial intelligence. Okay, artificial intelligence is purely math, scientific exercise, but when it come to and it becomes the computational. Okay, and it starts to solve the human problem formalized into the subset of computer science. Okay, and AI has changed the normally computation statistic paradigm to the modern idea that the machine learning could mimic the actual human capabilities, such as decision making, perform more human tasks. Modern AI into the two different tasks. One is a general AI and another one is applied AI. General AI is nothing but planning, decision making, identifying objects, recognizing the sounds, social and business interactions. Okay, the general AI comes into the picture like how you plan, decision making, identifying objects, right? Let's suppose if I am recognizing the sound, social and business interaction, then it comes to the general AI. Applied AI, it's something where driverless or autonomous car or machine smartly trade stocks. Okay, so that particular sense it will comes to the applied AI. Okay, all right. So make it a very understanding and intuitive understanding. Okay, I will just put it this way. I will make it very specifics. Okay, okay. So now artificial intelligence is a purely math and scientific search exercise, but where it becomes a computational. Okay, it started to solve the human problems formulas into a subset of computer science. AI has changed the original computer statistic problem into the machines could mimic actual human capabilities such as decision making, performing more human tasks. Modern AI into the two categories. Like modern AI is categorized into okay, modern AI is categorized into two categories, that is general AI and applied AI. Okay, general AI is planning, decision making. So let me make it like a canvas, folks. Okay, so now I will take this particular text. All right, I will just copy this and just try to formulate it. Okay, so what I do is I will just put it like this. Okay, so here like this AI. Okay. What is AI? Okay, so when it consider AI is a purely math and scientific exercise, but when it comes to the computational, it start to solve the human problem, formalized into the subset of computer science. AI has changed changed the original computation statistic paradigm to modern the idea the machines and could mimic actual human capabilities. Okay, so what we can do is here we can take it another this. So AI we can do it like this way. Okay, what's an AI? AI will be this one. Okay, it is a purely math which can mimic the human capability. Okay, so I will just put this and I will put it like this. Okay, so what we learn, you will understand why I'm doing this. Okay, I'm repeating again and again so that you don't have to read once again. Okay, so AI is purely math and scientific exercise. Okay, AI is nothing but purely math and scientific exercise. But when it become computational, it start to solve when it becomes the mathematical problems it when it's become like solving the mathematics, right? Mathematical like huge computation, huge complex problems need to solve, right? So it started to solve the human problems, then it becomes to tend to solve the human problems. Okay, so this is the one. It start to solve human problems. Okay, and machine could mimic the actual human capabilities, like just like more human tasks. Okay, I hope this you got the clear idea, right? So this I will just make it as two things. Okay, it become computational, number one. Okay, number two, what it will become, like this way. Okay, so I will just make it, drag it little bit bigger, so it will be very easy for you to understand the things. Folks, if you want this particular canvas, just let me know in a comment down below. Otherwise, just create it by yourself. Okay, so let me know if you want this. Okay, so in the AI, this is a thing. Okay, in the modern AI, it is a two categories. As a two categories, one is a general AI and another one is a applied AI. Okay, I hope this you like you are getting the idea. Okay, you're understanding what I'm trying to say, right? So I will just tell that modern AI into two categories. I will just add a card. Here also I will add a card. Okay. So into like this. Second. Okay. Okay. I hope this you got the idea, right? So if you wanted to do like this, you can attach like this. Okay. And like this. Okay. Applied AI autonomous car or machine learning smartly treat storms. Okay, so now what's a machine learning now? Instead of engineers teaching or programming the computers to have they need to carry out the task that perhaps computer could teach themselves, learn something without being explicitly programmed to do. So, okay, ML is the form of AI where based on more data and they can change the action and response, which will make more efficient, adaptable, and scalable. Example, navigation apps and recommendation engine. Okay, so we'll just take it this definition. Okay, we'll just copy this and we'll add it here. Okay, we'll add it here about the machine learning. Right, machine learning. What's a machine learning? You can go through this. Okay, machine learning is instead of engineer teaching programming computers how they what they need to carry out the task, the perhaps the computer could teach themselves. Okay, so we'll just take it like this, and we'll just take this as an example. Okay, so we'll just take it from this here. Okay, canvas. Okay, so Untitled AI, AI is this is this. Okay, then move AI into the two categories. There is a general AI, another one is an applied AI. Then applied AI, then it comes to the picture. Then what's a machine learning now? We are talking about that, right? So uh, what's going to do instead of engineers, if we want to change actions which can be efficient, adaptable, and scalable. Okay. So what we do is we will add it the definition, right? So this is the definition of the machine learning. Now, for example, what is an example for that? Hey Akash, you are telling that, but what's an example for that? Okay, so machine learning also divide into the two things. One is a definition, another one is an example. Okay. Okay. So instead of engineers teaching, like computers will teach themselves. Okay. So this is a machine learning, folks. Okay. All right. Then, so now here the classification of the machine learning. It is classified into supervised, unsupervised, and reinforcement learning. Okay, so I will make a document, folks, mapping mind map and all. I will do afterwards, and in the like in the next video, I will be going to talk about. In daily, you will be expecting two videos. Okay, one is recording, understanding the concepts part, and another one is mind map that will be going to get it end of the day actually. Okay, all right. So let me get back here. So now, what is a classification? Supervised, unsupervised, and reinforcement learning. Okay, so these are the three categories. Now, what's a data science then? So you will be talking about then supervised, unsupervised, and reinforcement. Then what's the data science then, Akash? Okay, so data science is just a term where various branches comes into the picture. Okay, like various tools, techniques, algorithms called from this fields. Okay, plus others handles the big data. Okay, the goal of a data science somewhat similar to the machine learning somewhat similar to the machine learning is to make an accurate prediction and to automate and perform the transaction in real time, such as purchasing internet traffic or automatically generating the content. Okay, so these are the things basically. Okay, now data science relies on math, less on coding. Okay, so we'll just write the copy this. Okay. Then data science relies less on math and coding, more on data, building a new systems to process the data, relying on the field of data integration, distributed architecture, automated machine learning, data visualization, data engineering, and automated data-driven decision. Data science can over entirely spectrum of data processing, not only the algorithm or statistics related to the data. Okay, this is a definition about the data science they are talking about it. All right, so we'll just make it this here. All right, so now what's a deep learning now then? So deep learning will just take it and make it understand what is the that field basically. Okay, so deep learning, okay, it's a technique for implementing machine learning. Okay, it is a technique for implementing the machine learning. All right. So ML provides, machine learning provides the desired output from a given input. Okay. But DL reads the input and applies it to the another data. In machine learning, we can easily classify the flower based upon the features. Suppose you want a machine to look at an image and determine what it represents, whether it is a human eye, whether it is a face flower, landscape truck, building, etc. Okay, so uh, machine learning is not as sufficient for this task because machine learning can only produce the output from a data set. Okay, whether according to the algorithm or based on an inherent structure of a data. Okay, machine learning is not sufficient. Only produce the output from the data set, whether according to the known algorithm or based on the inherent structure. You might able to use the machine learning to determine whether an image is a flower, say, and it would learn and get more accurate. Okay, but this output is a binary, yes or no, basically, right? And independent algorithm, it is not a data. In the image recognition case, outcome is not binary, not dependent on the algorithm, right? So neural network performs a micro calculations, so which computation on many layers. Okay, neural networks. Neural networks also supports the weighing data for confidence. So this results is a probabilistic versus deterministic and can handle the task that we require the human-like judgment. Okay, in order to tell that, if I wanted to summarize this data science, AI, and machine learning, so AI is nothing but purely mathematics and scientific. Okay, it becomes a computation when that particular thing that machine can solve using the this human problems. Okay, so AI can solve the human problems basically. Okay, and it can perform the human capabilities like such as decision making, taking the decision based upon the data, right? Then we understood like modern like AI is classified into two categories. One is a general AI and another one is a planned AI. Okay, so general AI is nothing but a planning, decision making, and identifying object, recognizing the sounds, and social and business transaction. Okay. Second, we understood about the applied AI, driverless autonomous car or machine learning smartly trade stocks. Okay. Machine learning is a instead of engineers to tell them like how to uh, program themselves what they need to carry out the task. Okay, we can teach the machine so that they can learn by themselves. Okay, so ML is the form of an AI where based on more data they can change actions and response, which make more efficient, adaptable, and scalable. Okay, and for that examples are navigation apps and recommendation engine. Okay, so we can classify it into this can be classified into two types. One is a supervised, unsupervised, and reinforcement learning. So we'll be going to do understand later parts. Okay, so we understood about data science is an umbrella term where various tools, techniques, and algorithms called from these fields. Okay, so goal of a data science is to make an accurate decision and automate the transactions such as purchasing internet traffic, automatic generating content, all the stuffs. So data science relies less on math on coding and more on data and building a new system to process the data. Relying on the like fields of data integration, data architecture, automated machine learning, and data visualization, data engineering, and automated data driven decision, data science can cover an entire spectrum of data processing, not only the algorithm or statistics related to the data. Okay, so it depends on all the stems. Okay, when you consider about the deep learning, like in the deep learning, it is an umbrella term of an data science itself. So in the like you are not specifically dedicated to towards a feature, you will give the input data, machine will tell you that what will be the if you give this image, it will going to talk about what this image is about. Okay, let's suppose if I wanted to take a camera and if I just wanted to my machine, my app or machine need to classify that whether this if I'm recording the particular video in laptop, what that object is about. Okay, so this is all about the things basically folks. Okay. Okay, all right. Now we'll try to understand what is the differences between supervised, unsupervised, and reinforcement learning. All right. So we'll try to understand that part. All right. So this is a thing we'll try to understand now. Mhm. Let me copy this. This is a question number two. Okay. So okay, so let's get started to understand about more into the depth. Okay, machine learning is a scientific study of algorithm and statistic models that computer system use to effectively perform a specific task without using the explicitly instruction, relying on the patterns and inference instead. Build a model by learning by the patterns of historical data with some relationship between the data to make a data driven prediction. Okay, types of machine learning as we saw, like supervised and supervised reinforcement learning. And supervised, what you know is like you know what will happen, what's the outcome is about. You know the parameters to train this particular model. Okay, it is nothing but a supervised model. Okay, so that is only here we are talking about. In supervised learning model, The algorithm learns a labeled data set to generate the reasonable prediction for the response of new data. Alright, so for this particular case in supervised, we have a two types. Another one is a regression, another one is a classification. Okay, so uh, like unsupervised learning is, what do you mean by the unsupervised learn? We don't have labeled data here. Okay, that algorithm tries to make a sense out of extracting the feature, co-occurrence, and underlying the pattern on its own. We can use the this unsupervised learning. Okay, so we have a clustering, we have an anomaly detection for that, we have association, we have autoencoders. Okay, for example, for the unsupervised learning. Okay, for now, what is a reinforcement learning now? Reinforcement learning is a less supervised and depends upon the learn agent determine the output. Okay, solution by arriving at different possible ways to best possible solution. Okay, so the summary of this particular question is try to understand supervised, which we know the label and we know the things what it is. Okay, okay, so you know what the things is all about. All right. You know what is happening. Okay, so like unsupervised, you don't know the what will be the prediction of that unclassified data. And reinforcement learning, like it will learn by its experience. Let's suppose take an example of autonomous car, right? Let's say take an example of AlphaGo, like chess, right? You make a move, like you, if you are intelligent chess, right, you will beat the machine, right? Then in the next time, if you take that move, that machine will able to understand and take the next move with that previous experience. Okay, so this is an example of reinforcement learning. Try to not, I'm not telling that whatever you are learning here, make it definition like that itself. Okay, like try to make it as simplified as an example. Okay, it's depends upon the learning agent. Okay, learning is a less supervised and it depends upon the learning agent determining the output. Okay, so this is a particular thing. Okay, so we'll just take it. Okay, what does it describe the general architecture? Okay, so I'll just paste this. Then describe the goal of general architecture of machine learning. So what will be the architecture of machine learning? We'll try to understand. Okay, so business understanding, data acquisition and understanding, then modeling and deployment. Okay, so these are the steps we will be going to do it. Okay, we'll try to understand one by one how the things is there. Okay, we'll try to learn that. Okay, so we'll just try to uh, copy and paste it and try to learn about it. Okay. Okay, so modeling is nothing but we try to understand about the business understand. So understand the given use case, and also it is good to know more about the domain for which the use case are built. Okay, data acquisition and data understanding is nothing but data gathering for the different resources, sources, and understanding the data, cleaning the data, handling the missing data, data wrangling, and EDA. Okay, exploratory data analysis. Okay, just a second. So, data acquisition and what you do is in the data acquisition, data understanding is like you will gather the data. Okay, that may gathering the data may be your database, maybe your from another sources like websites, and cleaning the data and handling the missing data. Okay, if any data is like, if you want perform any like whether the data is missing or any values is there or not, you will be going to go into the EDA stage. It is exploratory data analysis. Then this three is done. Then fourth is comes to the picture, that is modeling. Okay. In the modeling, what you do is you will do the feature engineering. You scale the data. You will select the features. Not all features are important. Understand this point. Okay. Not all features are important. You have to select which features are important for that particular business, which is required for that. Okay. Okay, so then we will be going to train the model based on trial and error method or by experience. We select the algorithm and train with the selected feature. Okay, all right. I hope this you got the clarity. Then we'll evaluate the model. Evaluation of a model is nothing but accuracy of a model, confusion metric, and cross validation. Okay, if the accuracy is not high, so to achieve the high accuracy, we tune the model either by changing the algorithm or by feature selection, by gathering the more data. Okay, then then it comes the deployment. Like once the model has a good accuracy, we deploy this model either in the cloud or any kind of a Raspberry Pi, okay, or any other place. Once we deploy, we monitor the performance of the model. If it is good, we go live with the model and reiterate all the process until our model performance is good. Okay, it is not done yet. Okay, what if a few days our model performs badly because of the new data? In that case, we do all process again, business understanding by collecting the new data and redeploy the model. So this is the steps we'll be going to do. Business understanding, you will start that business understanding, data acquisition. In the data acquisition, data source, data pipeline, environment, cleaning, wrangling, and exploration. Then you will build a model. You will do the feature engineering. You will train the model. You will evaluate your model, and then once again you will deploy that particular model. Okay, so you will deploy the model and you will uh, deploy it into the customer acceptance, and you will land this particular project life cycle. Okay, so this is the overall life cycle we'll going to do it. Okay, this will be done. All right, so these are the like internal architecture basically. Now we will go get back to another question, what is a linear regression? Okay, all right, so we'll take this. I hope you understand the linear regression. You will be fitting the best fit line, right? So that is only the objective of the linear regression, right? So linear regression is to establish a relationship between dependent variable and independent variable, one or more independent variable, to find the best fit of the straight line. The equation of the linear model y equal to mx plus c, where m is the slope and c is the intercept. Okay, so this is a particular thing, folks. Okay, so then, like in the about which diagram it is, the blue dots, we see the distribution y with respect to x. Okay, so we'll just take it here. Minimize the error by between the expected and actual value. Okay, so now next question will be going to understand, like it is a OLS stats model, ordinary least square. It's a stats model which help us to identify more significant features that can has a influence on the output. OLS model in Python has executed like this basically. Okay, so like this they are telling. Okay, so I will just copy this and put it into the Obsidian. Okay, we'll take question, this question number 5, and we'll just copy this. Okay, so we'll just take this. This will be executed like this. So higher the t value, the feature for the feature, the most significant feature is to the output variable. And the p value plays a role in rejecting the null hypothesis. And if p value is less than 0.05 for a feature, then we can consider the feature to be significant. Understand like significant, like how much percent of significant value we can consider whether to reject that hypothesis or not. Okay, so this is a particular thing that you need to consider about. Okay, all right, so this is a particular thing. So now we'll try to understand another question. What is a L1 lasso? Okay, lasso is a L1 regularization. Like main objective of creating a model is to make sure it fits the data properly and reduces the loss. Okay, poor performance, it will overcomes these regularization techniques come to overcome the overfitting. When now what do you mean by overfitting? The overfitting is a such condition where model will perform well on training data, but it will not perform well on test data. So that such condition is called as overfitting of overfitting, folks. Okay. Lasso regression is absolute shrinkage and selection operator. Least absolute shrinkage and selection operator. Okay. All right. So this is a L1 regularization. Then for L1 regularization, if you see here, cost which is equal to summation I equal to 0 to n yi minus summation j equal to 0 to m xi j wj whole square plus lambda. This is hyperparameter basically. This parameter they are adding to overcome the overfitting, folks. Okay. Summation j equal to 0 to m wj, absolute of wj. Okay. So here L2 regularization, what you do is you will square that. Okay. You will square and you will add another parameter lambda and you will add this regularization term. Okay. So this is a thing, and so this is a thing, folks. Okay, lambda 2 m, like pruning, regularization, etc. to avoid the overfitting. Okay, L1 is like feature selection, L2 is like reduce the overfitting. Okay, ridge lasso. Now this is very important, folks. Okay, try to understand this one. This one, in every interviews they will ask, what is the R square, where to use and where not. Okay, try to focus on this particular part now. Okay, R square is a statistical measure how close the data are to fitted the regression line. It's also known as coefficient of determination or coefficient of multiple determination for multiple regression. Okay, defined of the definition of R square is percentage of response variable variation that is explained by the linear model. Okay, R square is explained variation by total variation. Okay, so SSRES by SS total. Okay, R square which is equal to 1 minus SSRES by SS total. Sum of the total error by sum of the square regression error. Okay, this is a residual error we can call it as. Okay, so this is a problem with the R square. The problem arises when we ask question to ourselves. Is it good to help us as many as independent variable as possible? Okay, answer is no, right? Because we understood each independent variable should have meaningful impact and significance to help us the independent variable as possible. Okay, so like what will happen is will it improve the R square value? Yes, this is a basic problem of R square. How many junk independent variables you will add it are important independent. It will be impacting independent variable you add to your model. The square value will always increase. Okay, you add another parameter, R square value increase. Okay, so non-impactful bad value, we need another way to measure equivalent R square, which penalizes our model with any junk independent variable. Okay, so you add particular parameter, it add it uh, increases the value, increases the accuracy basically. Okay, so now next is mean square error. So mean square error, how close to the regression line set to the points. It does this by taking a distance from the points to the regression line. These distances are the error and squaring them. Okay, so see, this is the equation 1 over n summation I equal to 1 to n yi minus yi hat whole square. Okay, in the next video, we'll be going to talk about folks like why support regression, support vector. That part we will be going to discuss about. Okay, this video is long video. Okay, in the next video, we'll be going to discuss about why support vector regression. Since this is altogether 12 pages. Yeah. Okay. All right, all right. We'll complete it off day once itself, so it will be easy for us. Okay. Where support regression, difference between the support vector regression or simple regression model. In simple linear regression, you try to minimize the error rate, but in SVR, support vector regression, we try to fit the error within a certain threshold. Okay. We'll try to put the threshold for that. Okay, main concept we need to understand about is boundary, kernel, support factor, hyperplane. Okay, these are the main concept you need to understand: boundary, kernel, support vector, and hyperplane. Okay, these are the things you need to consider. Okay, all right. Then, like blue line, it is a hyperplane, red line is a boundary line. Okay, it is an hyperplane and this is a boundary line. Okay, so this is only the demonstrating soft margin, hard margin, that all stuffs will be going to come in this particular thing, folks. Okay, so our burst fit line is one where hyperplane has a maximum number of points. So how will you choose this? Like this particular point is there. Okay, where it is nearby, it will create the, where there will be nearby points will be going to create it, and it will be going to create this particular line between them. Okay, I hope that you understood. Like little bit, it is a complex. If you're not watch, if you have not understood the support vector machine, we'll get dive into it. You will understand in the day by day the things, folks. That's it about this video, folks. I hope you understood what the things, and you have to get the things. Main topic I have added, like you have to understand it is a statistical measure how close the data are fitted regression line. Try to understand, this is very important question, regression. uh, okay, so try to think about it. Okay, all right, that's it about this video, folks. In the next video, in the tomorrow's session, we'll be going to discuss about another. I will just give you a disclaimer of that. So what we'll be going to learn the things. It's a day two. Yeah, here day two. So we'll be going to understand. Okay, logistic regression. Tomorrow we'll be going to understand what's this thing, and we'll be going to understand in the depth. I will be not creating a separate notes, folks. We have already have a document, so I will just make you explain like how, what is the thing, what is there in the document. We'll try to understand and revise the things. Okay, so that's it about this video, folks. I hope you understood. In the next video, in the next tomorrow's session, we'll be going to discuss about logistic, decision tree, then entropy, information gain, Gini index, impurity, what is that and why we need that. Okay, that things sort of a things we'll be going to learn in the tomorrow's video. And what does it mean? What do you mean by pre-pruning and post-pruning? And what is a random forest algorithm? What is a variance bias trade-off? Right? That will be going to learn. and we will be going to understand about what is ensemble methods, bagging, boosting. Then we'll try to understand about the little bit about SVM classification, how they do, what they do, and what are the advantages and disadvantages, what are the new base and new base classification versus new base. Okay, so these are the things we'll be going to understand about, and what is a confusion matrix, what is accuracy in mixed classification rate and misclassification rate, how we will be going to do it, what is a true positive rate, what is a true negative rate, what is the false positive rate, for what is the false negative rate. These are the things in an interview also they will be going to talk about. What is a FN score, precision, recall. This will be going to learn in the tomorrow's video. That tomorrow's video will be very long enough to understand about each and everything. Okay, so that's it about this video. I hope you understood what's the current motive for 30 days we'll be going to plan it, and let me know. The one particular topic is still pending, that thermal printer. Okay, no one is interested. I'm not getting so much demands on that particular video, so I'm not recording that. Okay, so for the 30 days, we'll be going to plan this, and we'll be going to straightforwardly understanding that. Okay, why we are doing understanding and cracking the data science interviews basically, folks. Okay, all right, that's it about this video. I hope you enjoyed. You will understand.